This reaction here between calcium carbonate and hydrochloric acid is exothermic, right? So the answer to 5.1 is exothermic. Right, now we just need to explain why we're claiming that the reaction is exothermic. We can see here with clarity that the enthalpy change is negative, right? So our reason for 5.1, we're going to say that delta H is less than 0, right? If that is the case, then a reaction is exothermic. If delta H was greater than 0, then that reaction would be endothermic, right? And then moving to 5.2, the question says that let's calculate the average rate in grams per second of the above reaction. So we have a tablet of mass 2 grams that is placed in hydrochloric acid, right? And then after 30 seconds, the mass of the tablet was found to be 0.25 grams, right? And then our rate of reaction is supposed to be in grams per second, right? So we started with 2 grams and then we ended up with 0.25 grams. So it will be easy to find the change in the mass in that case, right? We would have 0.25 minus 2, which will be minus 1.75 grams. So that is our change in mass. So now we can say that the average rate will be equals to the change in mass divided by the change in time. We can see that our change in mass is negative, right? So we can put a negative sign here to combat 10. And then that will be equals to minus 1.75 divided by the time. What is the time again? That is 30 seconds. If yeah, that is correct, that is 30 seconds. And if you put that in your calculator, you shall get 0.06 grams per second, right? So now you might be asking yourself, I've seen you say that the rate of reaction is the change in the number of moles divided by the time, is the change in the concentration divided by the time, and now we're saying the rate of reaction is the change in the mass divided by the time. So which one really is it, right? You can use any, but most of the time the question is going to be specific on which one you're supposed to use, right? As you can see here, they said that we must use grams per second. If they had said we must use number of moles, we're going to convert that mass to number of moles, right? So that's how it works. You have to do what the question is asking you to do, right? If that is clear, then 5.3. So the tablet contains 40% calcium carbonate. Another tablet of mass 2 grams is allowed to react completely with hydrochloric acid. And then the question is saying that let's calculate the volume of carbon dioxide that will be collected. Assume that all the CO2 produced is from the calcium carbonate, right? Let me show you something. So we have CaCO3 plus 2HCl, giving you CaCl2 plus CO2 plus H2O, right? And then the tablet contains 40% calcium carbonate, right? So we can determine the mass of the calcium carbonate. So let's say we have the mass of the calcium carbonate. Then what are we gonna do next after we have the mass of the calcium carbonate, right? You need to know which steps you're going to take before you even calculate anything. I think that is the best way of doing it. So we have the mass of calcium carbonate, and then from the mass of the calcium carbonate, we're gonna find the number of moles of calcium carbonate, right? And then using the mole ratio, we're going to use the number of moles of calcium carbonate to find the number of moles of CO2. And then from the number of moles of CO2, we're going to be able to find the volume. Let's go ahead and find the mass of the calcium carbonate. So we have 2 grams of the tablet, right? But then of that 2 grams, 40% is calcium carbonate. So we can say that the mass of CaCO3 is equals to 2 grams multiplied by 40%, right? 40 divided by 100. And then if you compute that, you will get 0.8 grams. So we have the mass of calcium carbonate, right? So we have done the first step. Let's go to the second step, which is finding the number of moles of calcium carbonate. So we're gonna say that the number of moles is equals to the mass divided by the molar mass. So the number of moles will be equals to the mass, which is 0.8. Now we just need the molar mass of calcium carbonate, right? It is 100, right? And then if you punch that in your calculator, you're gonna get 8 times 10 to the minus 3 moles. We have the number of moles of CaCO3. Now let's find the number of moles of CO2 using the balancing coefficients. What do I mean by that? We're going to say that the number of moles of calcium carbonate divided by the number of moles of CO2 is close to the ratio of the balancing coefficient. The balancing coefficient of calcium carbonate is 1, right? We have 1 here. And then the balancing coefficient of CO2 is also equal to 1. So the number of moles of CO2 is equal to the number of moles of calcium carbonate, which is 8 times 10 to the minus 3 moles. So I have the number of moles of CO2. I've done the step. Now I can find the volume of CO2, right? Now how can I possibly do that? I'm going to say that the number of moles is equal to the volume divided by the molar gas volume. This is true when you are dealing with gases, right? Yeah. And then the number of moles of CO2, that is 8 times 10 to the minus 3. And then the volume, which we're looking for. And then this VM here, the molar gas volume, is a constant, right? At standard temperature and pressure. That is 22,4 decimeter cube. So we have 22,4 decimeter cube there. And then if we cross multiply, we're going to get the volume being equals to 0.18 decimeter cube, right? And just like that, we have calculated the volume of CO2, right? So you can see that being very intentional, knowing whatever you're going to do before you even start doing any calculation just makes your life easy, right? Let's move forward. 5.4. So 5.4 is saying that let's go through the question statement first. The reaction rate of similar tablets with excess hydrochloric acid of concentration 0.1 mole per decimeter cube at different temperatures is measured. The graph below was obtained. We can clearly see the graph. We have the temperature on the x and some 1 divided by time on the y-axis. And then the first question, 5.4, write down one control variable for this investigation. So what are we investigating here? We investigating the relationship between the reaction rate, right? We are investigating the relationship between the reaction rate and different temperatures, right? So those are the only things that we are investigating. We'll change in the temperature and then we'll look at the effect on the rate of reaction. So for us to have a good experiment, we need to keep all the other factors that affect the rate of reaction in check. We have to make sure that they are the same. Because imagine you change the temperature and you change the concentration at the same time, then you're not gonna know what is affecting what, because now you have a 2 variable equation, right? So here, since we have HCl as a solution, we can control at the concentration of HCl, right? So concentration of HCl, we need to keep it the same so that our results, are accurate. It's a fair investigation. And then apart from the concentration of HCl, we can also keep the surface area of the tablets the same, because if you tamper with the surface area, we know that it has an effect on the rate of the reaction. So concentration of HCl and surface area of the tablets, right? Or the tablets. I think we can also say surface area of calcium carbonate, right? That is 5.4. Let's go to 5.5 and see what is happening. For 5.5 says that let's write down a conclusion that can be made from the graph. So as the temperature is increasing, right, 1 divided by time is also increasing. the rate of the reaction is also increasing as the temperature is increasing, right? So we can say that as the temperature increases, 1 divided by time also increases, right? Instead of 1 divided by time, you can say the rate of a reaction, but you have to write it in full. Don't write it like this. Yeah, I can only do this, not you. Right. 5.6, use the collision theory to fully explain the answer in question 5.5. As the temperature increases, the rate of a reaction increases, right? Now we just need to explain that using the collision theory. Right. So the first point, so point number 1, when you increase temperature, the average kinetic energy of the molecules is going to increase. That is point number 1. And then point number 2, more molecules or more particles will have a kinetic energy which is equals to or greater than the activation energy. And then as a consequence of that, which is point number 3, we're going to have more successful collisions, right? And then more successful collisions at the right orientation gives us a higher rate of reaction. But so that is 5.5 in terms of the collision theory. All right. And the last question, 5.7, redraw the graph in the answer book on the same set of axes. Sketch the curve that will be obtained if HCl of concentration 0.2 mole per decimeter cube is now used. Label this graph, label this curve Y. So just a question for you guys. Do you think that the graph we're supposed to obtain is supposed to be above the graph we currently have, or it's supposed to be below, right? Please let me know in the comments what you think about that question and why you're saying so.